Hi, this is Janak Reddy Dubbaka. Welcome to DJR Physics Sir's Gold Mine Physics Problems for JEE Advanced. In this lecture, this is lecture 1 part 4. Here in this lecture we are going to discuss some more problems, that too integer type questions. See here, the assembly of two identical discs connected by light rigid rod is kept on a sufficient rough horizontal surface. Front disc is given by an initial angular velocity omega naught. The total impulse provided by all the forces on rear disc till the time it starts pure rolling motion. M is equal to 2 kg, R is equal to 1 meter. Here we can apply law of conservation of angular momentum. See, first initial angular momentum Li is equal to I omega. See, the front disc is rotating, but rear disc is at rest. Therefore, this becomes moment of inertia of the disc mr square by 2 into omega naught. This is a initial angular momentum. See, when this starts pure rolling, in that case final angular momentum, that is angular momentum due to rotational motion and also angular momentum due to translational motion. See, due to rotational motion I omega plus translational motion mvr, there are two discs, therefore into 2. But in pure rolling motion, V is equal to R omega, therefore omega is equal to V by R. Therefore, L final is equal to I means mr square by 2 omega V by R plus mvr into 2. Therefore, here R square cancel. L final is equal to, this is mvr by 2 plus mvr into 2. L final is equal to 3 mvr by 2 into 2. 2 gets cancelled. This becomes 3 mvr. This is a final angular momentum. Therefore, according to law of conservation of angular momentum, L initial is equal to L final. L initial is mr square by 2 omega naught, mr square by 2 omega naught, and final is 3 mvr. See here, m gets cancelled, r square, and here V is the velocity of center of mass of the discs. Therefore, that V is equal to, here is omega naught R by 6. This is the velocity of center of mass of the discs. Next, impulse means change in momentum, final momentum minus initial momentum. Here impulse I have to find out for rear wheel, not front wheel. Therefore, final momentum means mass into velocity, initial is at rest. Therefore, m into V means omega naught R by 6. Therefore, J is equal to, m is given as 2 and omega naught is 12, radius 1 by 6, 6 1s are 6 2, this is 4 kg meter per second. Therefore, J is equal to 4. Next one. Here, a uniform chain of length pi r lies inside a smooth semicircular tube AB in vertical plane of radius 1 meter. Assume a light disturbance start the chain in motion. If the velocity of the chain, velocity with which chain emerges from the end B of the tube, V is given, we have to find out N. Initially, it is in the tube, therefore, its center of mass, this is the initial center of mass. For semicircular arc, center of mass is 2r by pi, or 2r by pi. When it comes out of the tube like this, therefore, its center of mass is here. Therefore, total length is given as pi r. Therefore, this distance is pi r by 2. Therefore, initially center of mass here, finally it reaches to here. Therefore, the total length of the center of mass or decrease in potential energy is equal to increase in kinetic energy. Therefore, delta P is equal to delta Ke. Therefore, this is mgh is equal to half mv square. Initially it is at rest. M cancel. G into h means here the total distance between these two centers. This is 2r by pi plus pi r by 2. So this becomes 2r by pi plus pi r by 2, that is equal to half v square. Therefore, here G is 10, by cross multiplying this is 2, and here is LCM 2 pi. Therefore, this becomes 4r plus pi square r, that is equal to v square. Therefore, v square is equal to 20 into 4, r is 1 plus pi square by 2 pi. Therefore, v is equal to square root of 20 into 4 plus pi square by 2 pi. Here it is given as in the problem 4 plus pi square by 2 pi into n. Therefore, n is equal to 20. Next one. Here, a tall vessel having liquid of density 4 rho is made to accelerate rightwards with constant acceleration a is equal to 2g. A small spherical ball of density rho situated at one left bottom corner of the vessel is released from rest. If it collides with the vessel ball at point P shown in the figure, then the value of y is equal to. Here, vessel is having horizontal acceleration. See, first we have to consider this is a ball. On this ball, one force due to buoyancy, therefore, that is buoyancy force Fb is equal to V rho g. V into rho means density of the liquid 4 rho g, and its weight is W, that is equal to V into density of the body rho into g. Another one, a pseudo force is acting to the left side, that is I am taking pseudo force. Pseudo force is equal to here m into a. M means density into volume, density rho volume, but here acceleration is given as a is equal to 2g. Therefore, this is 2g. Next, here in horizontal direction there is a horizontal buoyant force. Horizontal buoyant force, this is due to the pressure difference. Here, when a liquid is at rest, for example, if you take 2 points in horizontal, same horizontal point, same horizontal level, these two having same pressure, but it is moving with an acceleration a. Therefore, one having greater pressure when you compare to 2. Therefore, there is a pressure difference. Due to that pressure difference, there is a force also exists, that is we called as మనం దాన్ని ఏమంటామంటే హారిజాంటల్ బయాండ్ ఫోర్స్ అంటాం. ఈ హారిజాంటల్ బయాండ్ ఫోర్స్ని వి రో జీ అని రాస్తాం. ఇక్కడ కూడా వి లిక్విడ్ డెన్సిటీ తీసుకోవాలి. లిక్విడ్ డెన్సిటీ వి లిక్విడ్ డెన్సిటీ 4 రో ఇంటూ యాక్సిలరేషన్ ఎంత 2g. ఇప్పుడు ఈ బాల్ మీద నెట్ అప్వర్డ్ ఫోర్స్ ఇన్ y డైరెక్షన్, F net in y direction is equal to ఇదేమో 4 rho Vg minus V rho g. This becomes 3 rho Vg. ఇది నెట్ ఫోర్స్ కాబట్టి నెట్ యాక్సలరేషన్ ఇన్ y డైరెక్షన్ ఏమవుతుందంటే 3 rho Vg బై మాస్ని డెన్సిటీ ఇంటూ వాల్యూమ్ రాస్తే ఇది 3g అవుతుంది. కాబట్టి బాల్కి వర్టికల్ డైరెక్షన్లో యాక్సలరేషన్ 3g. అట్లానే ఎఫ్ నెట్ ఇన్ ఎక్స్ డైరెక్షన్ రాద్దాం. ఇదేమో 8 8v rho g minus 2 rho vg. This becomes 6 rho vg. Therefore, acceleration in horizontal direction ఎంత అంటే by rho v తో క్యాన్సిల్ చేస్తే this is 6g అంటాం. ఓకే, ఇది 6g వర్టికల్ డైరెక్షన్. ఇక్కడ చూడండి, బాల్ ఇక్కడ నుంచి ఇక్కడికి రీచ్ అయిందంటే హారిజాంటల్ డిస్ప్లేస్మెంట్ ఏమో 8 మీటర్, వర్టికల్ డిస్ప్లేస్మెంట్ ఏమో y. కాబట్టి హారిజాంటల్ డిస్ప్లేస్మెంట్ sx అని రాద్దాం. ఇనీషియల్ వెలాసిటీ 0 కాబట్టి 1/2 ax t స్క్వేర్. sx ఈజ్ 8, 1/2. ay అంటే ay ఎంత, సారీ ax ఎంత, 6g into t square. Therefore, here 2 3 times t square is equal to 8/3g. ఇప్పుడు వర్టికల్ డిస్ప్లేస్మెంట్ sy is equal to 1/2 ay t square. మనం ఫైండ్ అవుట్ చేయాలి వర్టికల్ డిస్టెన్స్ y. 1/2 ay is given as 3g and t square is 8/3g. 3g cancel, 2 4 times. Therefore, vertical displacement y is equal to 4 meter. Therefore, answer y is equal to 4. ఇవి ఇంటీజర్ టైప్ క్వశ్చన్స్. ఓకే.